All right, so now we're going to be looking at distance time graphs. This is on page 22 of your notes. So what is a distance time graph? Well, it's just motion. Just remember that zebra that's moving, that's graphed on a graph that's comparing distance and time. So over time, how far did something go? So on these graphs, time is always on the bottom, on the x-axis, and distance is always on the side, the y-axis. So what is the slope, right? Slope we remember from math class. If we look at the line, we can generally get an idea of how much the slope is by how steep the line is. So slope can also be calculated by looking at 2 points from your y-axis and 2 points from your x-axis. It's also called rise over run. But let's just look at this graph a little bit closer. So we're measuring time in seconds, so 8 seconds total, and distance in meters. And it looks like there was 25 meters traveled total between these three people. Someone on a bike, someone running, someone walking. So the slope of a distance time graph is distance over time. If you remember, if that's ringing any bells, that's the calculation for speed, distance over time. So the slope of a line is actually the speed. So let's look at this graph. Which person has the slowest speed? If the steepness of a line represents speed, which one has the slowest speed? The walker, right? Even though this gentleman is really getting his speed walking on, this line has the least steepest line, so it has the slowest speed out of these three. So the y-intercept is a line where, is a point where the line crosses the y-axis. The y-axis, remember, is on the side. So it's basically where the object started. If this is distance, then that's where the object started, and that's where we started measuring their speed over time, right? Does it always have to be 0? No. In this case, it's 0, because it's right at the origin of the graph. But in this case, the y-intercept starts at 3 meters. That's where the object started before it started traveling over time. So let's look at this mess of a graph, right? All of these lines, all 5 lines, are straight lines. So what does this mean? Well, if it's a straight line, that means their speed are constant. It's not changing. They're not speeding up, they're not slowing down, they're traveling at a constant speed. Or are they all speeding up? Or are they all slowing down? Take a second to think, what does that mean when all 5 lines are straight lines? It means that their speeds are constant, right? Let's look at something else. So let's focus on line A, B, and C. So A, B, and C. Which out of these lines has the fastest speed? Out of A, B, and C, which has the fastest speed? And how do you know? Line A is the steepest line compared to B and C. Now look at A, B, and C again, but now which one has the slowest speed? Line C, right? Because it has the least steepest line compared to A and B. What is the speed of line D? 0. How do you know? The line is flat. There's no change in distance over time, so no speed. So see how, again, the y-axis is distance, It's 15 meters, and even through the whole time of 6 seconds, line D didn't go anywhere. So imagine that this was a person walking. They just stayed at 15 meters on like a high school track. They just stayed at the 15-meter line that whole time. They had no speed. So did this person start in the same place as A, B, and C? Look at their y-intercept. Did this person start at the same place? No, right? How do you know? Its y-intercept is in a different place, 15 meters. A, B, and C all started at 0 meters. So take a look at line E. This line has a negative slope. What does that mean? It's moving in the opposite direction. So whereas A, B, and C started at 0, this person started at the 35-meter marker line and then actually went backwards to reach where everyone else started at 0. Its speed is still positive. Its speed is still positive and constant, but it's just that they were going backwards. So what is happening at this dot? We have E and C kind of colliding, and that means they're at the same place at the same time. Hopefully they didn't hit each other, but probably if you interpret this as people running or walking, that means they smacked into each other, right? They're at the same place at the same time. So, what does it mean when a line is curved? So we still have our distance and our time. This line is going up, and it's not straight, it's curved. This line's going down, and it's curved. Well, this is acceleration. So you can see over time we started constant, and then actually we started to speed up, and then our rate of distance over time increased. And so that's why you get that curve. Same thing for this one, only you're slowing down. Your speed's not constant, otherwise it would be a straight line. It's starting to curve and go downward, so it's slowing down, so you should have a negative acceleration or slowing down. So on a distance and time graph, if an object is speeding up or slowing down, you will notice it as a curved graph, a curved line, instead of a straight line.